All right, all right. So today we'll be solving quadratic equations by completing the square. So if you did not watch our lesson on intro to completing the square, you really should watch that before you start doing this assignment. All right, so I have a quadratic function. X squared plus 10x minus 11 is equal to 0. Um, you don't always got to factor to find your solutions or to find your roots or to find your zeros. There are other options, and this is an option. We can solve it by completing the square. So, first things first, this method best works when A is 1. Remember, my A value is 1, B is 10, and C is negative 11. So this method best works when my A value is 1. It's nice and clean and easy. All right. So first things first, we got some rules and I got them listed here and we're just going to follow them. It says make sure that the A value is 1. It is. So we go down to step 2. Use inverse operations to move the constant to the other side of the equations. So I got to remember what a constant is. A constant is a number that stands alone. It ain't got no variable. So my constant is negative 11, and I need it to be on the other side of the equation. So the inverse of minus 11 is plus 11. So I'm going to add 11 to both sides. All right, so then I get x squared plus 10x, and I got a little blank right here. It's equal to 11. Now it says determine the value of C that's going to create a perfect square trinomial. So that is why we did our lovely intro to completing the square yesterday. I need to figure out what number is going to create a perfect square trinomial. So in the meantime, I'm going to add a box right here, but a square actually. I'm going to add a square right there. So the rules of solving equations say if I add a square to one side of the equation, then I got to add a square to the other side. All right, so I need to figure out what value for C is going to make this a perfect square trinomial. Well, what is half of 10? It's 5. So that means this side is 5 and this side is 5. Well, what happens when I square 5? I get 25. So 25 is going to make this a perfect square trinomial because remember, half of 10 is 5 and 5 squared is 25. Well, if I add 25 to one side in my box, I got to add 25 to the other side in my box. All right. Now it says factor my perfect square trinomial. Well, I know that my square has a side length of x and a positive 5. So I just factored it. And 11 plus 25 is 36. All right. Now, the goal is to solve for x, but x is being raised to the power of 2. So the inverse operation of getting rid of a square is taking the square root. So to get rid of a square, I have to take the square root. Well, if I take the square root of one side of the equation, I got to take the square root of the other side of the equation. Boom. So what happens when you take the square root of a square? Guess what happens to the square? It's gone. And I'm left with x plus 5. But what about the square root of 36? If I take the square root of 36, I can get a positive 6 or a negative 6. So why do you say that, Miss Carter? Because 6 times 6 is 36. But what is negative 6 times negative 6? It's also 36. So when I take the square root of a number, it can either be positive or negative. All that means is that this could be positive 6 or a negative 6. So solving for x. X plus 5 could equal a positive 6, or x plus 5 could also equal a negative 6. Now I just got two different equations that I got to solve for. So isolating x, subtract 5 on both sides, and x is equal to 1. All right, x plus 5 is equal to negative 6. Subtract 5 on both sides. And x could equal a negative 11. So x could equal negative 11 or it could equal a positive 1. Easy, right? Okay, well, what if my a is not 1? Is it going to be difficult? Not necessarily. So I want my a value to be 1 because that's when it best works. So what is my a value? 4. Well, how can I make my a value be 1? Divide everything by 4 to get rid of the coefficient. So I would divide every term by 4 because that's just how equations work. Well, this cancels and I'm left with x squared. Now a is 1. 16 divided by 4 is 4. Negative 12 divided by 4 is a negative 3. And 36 divided by 4 is a 9. Now my a value is 1. So my step 2 says use inverse operation to move the constant to the other side of the equation. I need this constant move over. So the opposite of subtracting 3 is adding 3. And if I add 3 to one side, got to add it to the other. And I get x squared plus 4x. Got a little blank right there, so I'm going to put me a little square right there just to fill my spot. 9 plus 3 is 12. And if I added a little square to fill my spot on one side, I got to do it on the other side. All right, determine the value of C. Trying to create me a perfect square trinomial. So, half of 4 is 2, and 2 squared is 4. So, 4 is going to complete my square. But if I add 4 in my square on one side, I got to add 4 on my square on the other side. All right. Now I need to factor my perfect square trinomial. Well, I knew that both of these have a side of 2, of x plus 2. So x plus 2 squared is my factor. It's me factoring that perfect square trinomial. And 16 and 12 plus 4 is 16. All right, the goal is to solve for x, but what about this square root? I can't just be adding 2 and all of that. I got to get rid of the square root. I mean the square. So the inverse of a square is taking the square root. So if I take the square root of one side, I got to take the square root of the other side. So what happens when you take the square root of something? The square is gone. So I just get x plus 2. And I'm taking the square root of 16. That means it could be a positive or a negative 4 because 4 times 4 is 16 and negative 4 times negative 4 is 16. So all that means is I can have a plus 4 or a minus 4. Now I'm still trying to solve for x. So x plus 2 could equal a positive 4 or x plus 2 could equal a negative 4. And let's just solve for x. So subtract 2 from both sides. And x could equal 2. Subtract 2 from both sides on this one. And x could equal a negative 6. So in this case, x could be negative 6 or it could be a positive 2. All right, any questions, please feel free to ask me in class.